Hello everyone. Let's discuss about a very important topic in DBMS. One is mapping cardinalities and the relationship sets. Okay, now we'll be discussing what is what, how relationships are maintained in between the entities within a database system, how to identify them. So if you come to the mapping cardinality, first of all, this cardinality defines the number of entities in one entity set. This can be associated with the number of entities of other set via a relationship set. So the mapping cardinalities determines like how many number of entities are in relation with the other entities. Okay, for that purpose, if you consider A and B as two different entities, then one entity from entity set A can be associated with at most one entity of entity set B and vice versa, then that is said to be a one-to-one cardinality relation. That means only one entity from this entire entity set will be related to another entity. You'll better understand when we go to the next thing, that is one to many. That means one entity from this particular entity set A will be associated with many other entities in the entity set B, then that is said to be a one to many entity set. So if you can understand here, that is, if you consider entity A, in an entity set A, there is the first entity here. This is associated with two other entities from entity set B. This is said to be one is associated with two other entities, nothing but many entities. Then we say this is one to many. But if you consider the third one, this is said to be one to one, and this is also said to be one to one. But still, if you consider the first one, this first one alone is associated with two other entities, or it can be associated with 3, 4, 5. Then that is said to be one to many cardinality relation. Next, it is many to one. That means from this entity set, from the first entity set, it is getting associated with only one entity from the entity set B. Then that is said to be many to one. So if you consider the first one, this is said to be one to one, that is fine. Second one to second one, one to one, let us suppose. Third one to fourth one to one. But fourth one again is associated to the second one of entity set B. Then that is said to be a many to one in cardinality relation. That means that means the entity set in an entity set A, if only one is associated with the other, we say it is one to one. If one is associated to many things, we say it is one to many. And if many are associated with only one, then we say it is many to one. Okay. The next thing is many to many. That means from the entire entity set A, many entities from the entire entity set A are associated with many entities from the entire entity set B. Then we say that is many to many. See here, the first two are one to one, but the second one is associated with second one of B as well. The second one of B is associated with fourth one of A, and fourth one is again associated with fourth one of B. That means one entity from A can be associated with more than one entity from B and vice versa. Then that is said to be many to many. These are called as mapping cardinalities: one to one to many to one, and many to many. These are all said to be mapping cardinalities among the entities. First of all, what are entities in our DBMS? So entities are represented by means of rectangles. Okay, whenever we see a rectangle, we should say, or we should consider it as an entity in DBMS. And see, this determines if you can understand it with respect to a table. This determines attribute names, student, teacher, table names, student, teacher, projects, etc. Okay, now each entity have certain attributes. Attributes are nothing but properties of these entities. Nothing but in tables, these are nothing but called as attribute values, if you can remember. Okay, these are attributes of the properties of entities here. That is, if you consider student can be better described by their properties like name, roll number, birth date, age, marks, college, course, all these things. So if you wanted to describe a student, you'll be describing it through various properties. Those are all called as attributes. Those are represented in this particular shape, oval shape. Okay. So now, if at all if these attributes are composite, okay, then they are further divided. See something like this into tree-like structure. See if you have name. This may have first name and last name. So this will be divided into first name and last name. Similarly, birth date. Birth date will be divided. Birth date will be divided into many other things like date, month, and year. So these are all said to be composite attributes. If they can be further divided, then such attributes are said to be composite attributes. Okay. So now, when there are multi-valued attributes, they are depicted by double eclipse. See, in the this is used to describe the ER diagram. Okay, so for an ER diagram, a single entity that we are describing here. So a single entity will have n number of properties. Those are called as attributes, and these properties can be further divided. That particular attribute is said to be a composite attribute. Now I am describing about multi-valued attributes. Multi-valued attributes, those are described by using a double eclipse. What do you mean by that? It is meant that, see, we are saying that phone number is a multi-valued attribute. It means that for a student can have two phone numbers. A student can have two phone numbers. Then that is said to be a multi-valued attribute. Okay. Can a student have two roll numbers? No, impossible. So that is a single attribute. You are not describing anything or you are not talking about this. If you wanted to come here, a student can have two names, nickname and official name. Okay. Then in that case, nickname one entity, one attribute, official name another attribute. So name will be a multi-valued attribute. Coming to official name, that will be a composite attribute which can be divided into first name and last name. I hope you understand. Nicknames again will not have first name and last name. Okay. So these are what are called as multi-valued attributes. There are other type of attributes called as derived attributes. Derived attributes are nothing but the attributes which can be derived from some other attribute. Okay, so those derived attributes are specified by dotted lines, dashed eclipse. So here we are saying that age is a derived attribute. How can you derive that? You can derive it from the birth date. Birth date. If you wanted to know the age of a particular person, particular student at present, you should first know about the birth date. So from today, you'll minus the birth date, then you'll be getting the age. Yes or no? So derived attributes are depicted by dashed ellipses. Derived attributes are those attributes which can be derived from some other attributes. So how many types of attributes have we seen now? We have seen composite attributes, multivalued attributes, and derived attributes. Okay, so now we wanted to go through the relationships. Relationships are determined by a diamond shape in terms of a diamond shape. So the relationship is determined in between two entities, and this is the structure of a relationship. Okay, so these are represented by diamond shaped box. Name of the relationship is written inside the diamond shape. All the entities which are in rectangle shape will be participating in the relation, and they are connected by a line, so binary relationship is nothing but the relationship which exists between only two entities. A relationship where two entities are participating is called as a binary relationship. Okay, cardinality is the number of
instance of an entity from a relation that can be associated with the relation, like one to one, one to many, many to one, and many to many. So if it is one to one, the cardinality is defined as 1 is to 1. One entity is participating in relation with another entity. If it is 1 to n, you will say it as 1 is to n. 1 is to n determines 1 is to n determines that one entity is participating with n number of entities. Okay, that is only one instance of entity on the left and more than one instance of the entity on the right can be associated in this relation. Now this is called as one to many relationship. The next one is many to one relation, which is described as n is to 1. When we say n is to 1, that means many entities on the left hand side are in relation with one entity on the right hand side. That is called as many to one relationship, and the cardinality is marked as n is to 1. Okay, coming to many, that is the entities, many entities on the left hand side will be in relation with many entities on the right hand side. That is said to be n is to n relationship, and they are marked as n is to n many to many relationship. Is this clear? So ER diagrams are better described in this way, like using this cardinalities, mapping cardinalities 1 is to n, 1 is to 1, n is to 1, and n is to n. Is this clear? So participation constraint here, total participation, each entity is involved in the relation. If each entity is involved in the relationship, then the total participation is determined by, represented by double lines. And if it is partial participation, not all entities are involved in the relationship, that is called as partial participation, and it is represented by single lines. By using these concepts, we should be able to derive or draw an ER diagram. One of our exercises can be simply drawing a ER diagram for banking system, banking application system, library management system, anything. So if you consider banking application or library management, let us suppose, because you will be very much familiar with the library. So how do you do that? You'll have a student, you'll have a librarian, you'll have a card with you. All these are related. Yes. And coming to, if it is a digital library, you'll also have a system. Okay, so when you say that students are using the digital library, then in that case, student, not only one student will be associated with a single entity here called as system, but depending upon the timings, many students can use the same system. So in that case, we can write it as many to one relationship. In that case, we can write it as n is to n, n is to one relation. Okay, and the same book, a library consists of books, so some same book can be used by many people. Even then we can say it is many to one. And if it is from book to students, it is one to many. Coming to librarian, the single librarian is associated with all the students, so that is one to many. From librarian to students, it is one to many. Newspaper, many to one to many. Okay, if you consider relationship between a library card and a student, it is one to one. A student will have a single library card, and the same library card will be having only by that particular student. The same library card can't be repeated for many students. So student card and student is again one to one relation. Is this clear? This is how the library management system works, and this is how you should draw the ER diagram. And all these are related by using this relationship, that is diamond shape, rhombus shape in between. Okay, here you'll be writing it as library management system. Sides, all the entities are, student is one entity, student card is another entity, librarian is one entity, book is another entity, as well as system, some monitor, CPU, some PC, person, desktop is one entity. Now you need to provide relationship among all these entities. This is how you'll be describing the ER diagram using various mapping cardinalities. You should provide this, whether it is 1 is to n, n is to 1, many to many, 1 to many, so 1 to 1, and so on. Okay, this is how you'll be depicting the ER diagram using various entities, their attributes again. See, if you consider student, student will have student ID, student name. That is enough, I guess, there. More than that, it's not required in a library management system. Okay, what about card? Card also will have student ID, student name. If at all, you'll have various rows which determines the book number. Yes or no? So card will have an attribute called as book number. Coming to librarian, librarian also only name is enough. Only an attribute called name is enough for librarian. Not much for a student is required there. Coming to the monitor, the desktop which you are using, it will have its own properties like what can be, it can be screen size. Max we can go for screen size here and the configuration if at all required, and company of the system. Okay, in this way, you will be providing various attributes to the entities provided in the library management system. Is this clear? So this is what is mapping cardinalities and ER diagrams. This is how you should show your ER diagram. If at all, if you have composite attributes, as we said, student name, there is an attribute called student name. You'll have first name and last name. You can provide those composite attributes. Student age, date of birth, there will be date of birth, so you can provide a derived attribute called age. Multivalued attribute called phone number. All these things can be done. Librarian will have, you will be using his phone number, so let us add an attribute called phone number to librarian. Then in that case, librarian will have a multi-valued attribute called as phone number. All these things can be depicted in your ER diagrams whenever it is required. Hope you understood well. Thank you.